Good morning, ladies and gentlemen, or good afternoon, whatever the case may be. Today we're going to talk about Unit 6, Part A, Lesson 4, the Trapezoidal Method. In the previous lessons, we learned the right-hand, left-hand, midpoint rule to approximate a definite integral. This is what we're going to use the trapezoidal method to, is to approximate a definite integral. This is going to be a most efficient way to approximate a definite integral. I'm not sure if the most efficient way is a good terminology. It's going to be the most accurate way to approximate a definite integral. We know that for certain. So recall, the first thing we have to do is go back into our time in geometry and find the area. Use the formula to find the area of a trapezoid. So here I have a trapezoid. The area of the trapezoid is 1/2 sum of the bases times the height. 1/2 sum of the bases times the height. And so example 1, I have this trapezoid. If the lengths of the bases are 4, here are the bases. The bases are parallel. It's quadrilateral with one pair of parallel sides. If the length of bases are 4 and 7 and the height is 7, let's find the area of that trapezoid. The area of that trapezoid then is going to be 1/2 sum of the bases times the height, which is 7. So it looks like this is going to be 4 plus 7, 11. 11 halves times 7. And whatever that rascal is going to be, I believe that's going to be 38.5. 38.5 units squared. We're not given units here, but we know when we mostly talk about applications of definite integrals, we are given the units, so make sure you put the units down. So this is, we don't know what the units are, but right now units squared. So let's go back. Let's do another example. Example number 2. For this example, the height is the same as one of the sides, which is not a leg. So what they're saying here is this is going to be your height right here, and is one of the sides. And here are my parallel legs, if you will, of the trapezoid. So for this particular trapezoid, the lengths of the bases are 4 and 8. That guy is 4. This guy is 8. And the height of the trapezoid is 3. So let's find the area of that. The area of this trapezoid is going to be 1/2 sum of the bases, 4 plus 12. Pardon me, 4 plus 8, got a little ahead of myself, times 3, if you will. And this is going to be 4 plus 8 is 12, divided by 2. I believe that's going to be 18 units squared. Check my arithmetic on that, please. And what we've done here is this is exactly the same trapezoid. So these are the exact same trapezoids. The only difference being is that this trapezoid is standing up on one of its sides. Here are the parallel bases. And when we use trapezoids to approximate a definite integral, we have to look at our trapezoids standing up, if you will. And these are going to be the bases of that trapezoid. The bases of the trapezoid have to be parallel. So same thing here. I've got the height is 3. The bases are 4 and 8, and then the area is still 18 units squared. So, okay, so we have to start looking at trapezoids standing up like that. Okay. All right, let's go to the next page. Next page is back to calculus, trapezoidal approximation. Let's use 3 trapezoids of equal heights. Oh, equal heights. The heights here, if I go back to this, what is the height of this trapezoid here? Ah, man, this is the height. So when we're going to use the trapezoid approximation on definite integral, the height of the trapezoid will be some change in x. So the height of the trapezoid will be some change in x because we're going to stand the trapezoids up. This is one of the things that will be confusing on using the trapezoidal method. So let's go back to my calculus problem. So I want to approximate this definite integral of ln of x from 2 to 5. I want to sketch the trapezoids on the diagram and show the expanded form. So the first thing I'm going to do is partition and this is the area that I want. And I'm going to use 3 trapezoids of equal heights. Heights are going to be some change in x. And here's going to be my trapezoids. Here's my 3 trapezoids. And if you look, golly gee, those 3 trapezoids are going to be almost precisely the exact value of that definite interval. So here are my heights right here. These are my change in x's. Those are 1. Those are my heights of the trapezoids. The heights are going to be 1 each time because I want of equal heights. And this is my delta x. Each one of these heights are going to be 1. And if I look at this, here are the bases of the first one. These are your function values. And these vertical lines are indeed parallel. So this is my first trapezoid. So I have 3 trapezoids. I'm going to label them trap 1, trapezoid 2, and trapezoid 3. And I'm going to find in expanded form, the area of trapezoid 1. I'm going to employ the formula. It's going to be 1/2 times the sum of the bases. And the sum of the bases here, the bases are going to be f of 3. But let's start with f of 2 plus f of 3 times the height, which is 1. That's trapezoid 1. So this is f of 2, and this is f of 3. The function values are the bases of the trapezoid. So that's trapezoid 1. Trapezoid 2 is going to be 1/2 sum of the bases. And what are the bases this time? F of 3 plus f of 4 times the height, which is 1. So this is your f of 3. Let's use a different color here. I'm not quite sure what color to use. This is going to be f of 3. This is going to be f of 4. Those are the bases of trapezoid 2. The height is going to be 1. And then trapezoid 3, looks like we're going to have to put trapezoid 3 down here. And then trapezoid 3, I'm going to add this to, it's going to be 1/2. And what are the sum of the bases? It's going to be f of 4 plus f of 5 times 1 again, because 1 is the base. My 4th one. And so what I'm going to do now is I'm just going to take my calculator and I'm going to find these function values. So what I've done is I've written the expanded form down below here. I didn't need the ones and try to follow what I've done here. So this value here is f of 2. This value here is f of 3. And notice I have 2 f of 3s. I factored the 1/2 out because I have 3 terms here. This term, this term, this term. And I factored out the 1/2 and just put it out here for no other reason than I was lacking some space here, if you will. So this is f of 2, this 1.0986, this is f of 3. I have 2 of those, this guy and this guy. I have 2 f of 4s. F of 4 is 1.3863, and I have 1 of f of 5. This is an f of 5 here. Boy, that's a really poor f of 5, but this is your f of 5. I added those 1, 2, 3, 4, 5, 6 values. Interesting. 1, 2, 3, 4, 5, 6 values together and divided them by, and you'll have to check my arithmetic, and I believe that came to 3.3214. That's an estimation for this definite interval. And if you notice, one thing we want to notice, this particular graph is concave down. So this approximation, it's really, really hard to sketch because it gives you such a precise, these lines, these segments are going to be below this graph that's concave down. So this estimation is going to be less than the actual approximation. I'm going to go to my graphing calculator and I'm going to find this definite integral. I have my graphing calculator pulled up. I have ln of x. I want to make sure that I'm going to need at least 6 because I'm going to go to 2 to 5. And so I'm going to go second calculate. 7, I want that definite integral from 2 is the lower limit, enter to 5, upper limit, and that's 3.6608. 3.6608, 3.6608, and that's the actual area, and that is indeed greater than this approximation. But if you notice, golly gee, that approximation is very, very close. So the trapezoid approximation gave us a very good estimation for the actual definite integral. Let's do another example. So we're going to use a trapezoid approximation with 4 intervals to estimate this integral from 2 to 3 of 2 over x squared. So here I have 2. I'm just going to label this. Whoopsie. I'll do some vertical lines here. This is going to be 2. My x2. This is my x3. And I'm looking at this graph here of 2 over x squared. And I want 4 intervals. So I want 4 trapezoids. The first thing I need to do is figure out what delta x is. And we know that delta x is going to be our height. And we're going to find that delta x, or the heights of our trapezoid, just like we did finding the bases of the rectangles. The difference here, again, we know the bases of the rectangles were delta x. If I use the trapezoidal approximation, the heights of the trapezoids are going to be delta x. Nevertheless, what's delta x? It's going to be 3 minus 2 divided by the number of trapezoids I want to use, and I want to use 4 trapezoids. So the height of each trapezoid will be 1/4. And I can easily divide this partition into 4s. Those are my 4 partitions. And this is going to be my first trapezoid. And again, we're going to see, hey, golly gee, looks like, again, those trapezoids are going to be a pretty good darn estimation. Let's go green on this one. And the other thing I'm going to say as I sketch these 4 trapezoids is that since this graph is concave up, and it's really hard to see, these segments that connect the top bases of the trapezoids are going to be above. So when I do my estimation with 4 trapezoids, it's going to be greater than the actual definite integral. So here's my 4 trapezoids. Trapezoid 1, T2, T3, T4. And what I have to do is find these endpoints of my partitions. And keep in mind my delta x is 1/4. So this first partition is going to be 2.25. This is going to be 2.5. This is going to be 2.75. And this last endpoint here, well, we know already that that's 3. So, and I'm going to sketch my, let's get all this these little marks out of there. I'm going to write my sum in expanded form. So I have trapezoid 1. Trapezoid 1 is going to be, again, 1/2 sum of the bases. The sum of the bases are going to be, f of 2 plus f of 2.25. This time the height is going to be, these guys are all going to be 1/4. So the height is going to be 1/4. That's trapezoid 1. Keep in mind I have 4 trapezoids. Trapezoid 2 is going to be 1/2 times f of 2.25 plus f of 2.5. Again, this is going to be multiplied by 1/4 because that's the height of the trapezoid. Trapezoid 3 We're going to add these guys together. Trapezoid 3, again, it's going to be 1/2 times the sum of the bases. This sum of the bases are going to be f of 2.5 plus f of 2.75. That's 1/2 sum of the bases. The height is going to be 1/4. And then I'm going to add to that trapezoid 4. And trapezoid 4 in like manner is going to be 1/2 times f of 2.75 plus f of 3. And again, times the height of 1/4. So those are my 4 terms. And if you look very carefully, and if this were an AP test, they want to see this expanded form here, because that demonstrates that you understand the trapezoidal method. What I'm going to do now is each of these terms, if you notice, I have this guy plus this product, plus this product, plus this product. Each of these products have a factor of 1/8. I'm going to factor the 1/8 out. And what I'm going to do is just put the function values. This is going to be f of 2 plus f of 2.25. And how many of those 2.25s do I have? Well, I have one here and one here. So I'm going to multiply that by 2. And I'm going to add to that actually 2 of f of 2.5, because I have f of 2.5, f of 2.5. I have 2 of those, plus, and then I have an f of 2.75. And how many of those do I have? I have 2 of those as well. So I'm going to multiply, I'm going to add 2 of those rascals. And then the last one, I only have 1 of this f of 3. And that's going to give me my approximation for that. I'm going to go to my calculator. I'm going to find these values. Okay, so let's see what I did. I actually went to my calculator in the table feature, and I actually found these values here at the 2. And I want to just, you can pause the video and double check my arithmetic. I actually double checked my arithmetic, but you certainly, please, if you feel the need, go right ahead. And then this sum right here equal 2.681 divided by 1/8, or multiplied by 1/8. So this is going to be right here. This is an approximation of the definite integral from 2 to 3 over what was our function, 2 over x squared. And I would ask that you go to your calculator and actually calculate this value. This value is equal to 1/3, which is very, very close. So again, we got the trapezoidal method, a very, very close approximation to the definite integral. So let's look at the final example from this particular lesson. You can always pause the video if you need to look at those numbers. I'm not going to bore you in the video calculating these values for you. And I'm going to do one more example and let you do the final example on your own. So there's 2 examples 4 in the textbook, and that's unfortunate. Someone who ever wrote the textbook can't count. So let's look at example 4. The following table of values give the outputs of a continuous function f for certain input values. Plot the data from the table and use the data to approximate the integral from 1 to 7 of f of x dx with 3 trapezoids. So I don't know what the rule for the function is. All I know is this data. So if at 1, it looks like the range of 8, the outputs range from 8. So I'm going to go 2, 4, 6, 8, 2, 4, 6, 8, because this 3 value goes all the way up to 8. So let's plot my data. I'm at 1, 5, so 1, 5 is going to be about right there. 3, 8 will be up here. I have 4, 7. 4, 7 is going to be there, and I have 7, 2. So 7, 2. So this is a continuous function. We really don't know what the function looks like. All I know are these data points. And I'm going to approximate that with 3 trapezoids. So I need to partition this in 3 partitions from 1 to 7. And I'm reluctantly, I'm not going to reluctantly, I'm not going to sketch the function. What I'm going to do is sketch the trapezoid. So here's your trapezoid 1, and I'm going to use my change in x's to define my partitions. I want 3 trapezoids where I'm given 4 points. Here's my 3 partitions. This is going to be trapezoid 1 right here. This rascal here will be trapezoid 2. And this rascal here will be trapezoid 3. So there's my 3 trapezoids. These are very common problems that you will see for an AP style test. And what's the difference, or what's not the same on all those trapezoids? What's not the same is the heights of these trapezoids all change. So that's going to be your difference with these trapezoids. We're still going to approximate it with 3 trapezoids. And this is actually going to be an easier problem than one we did, or less convoluted, if you will, not as many decimals. So we're going to go, and I'm still going to write it as trapezoid 1 plus trapezoid 2 plus trapezoid 3. What's the area of a trapezoid? It's going to be 1/2 sum of the bases. Well, here's your first base. Let's sketch trapezoid 1. These are your bases. The first base is going to be output for 1, which is going to be 5, plus the output for 3, which will be 8. Hey, what's the height of this first trapezoid? The height of this first trapezoid is 3 minus 1, which is 2. So that's your first trapezoid. What's the area of the second trapezoid? Again, it's going to be 1/2 sum of the bases. And what's the bases this time? Let's do purple for this trapezoid. Well, it's going to be the function value at 3, which is going to be 8, plus the function value at 4, which is going to be 7. And what's the height of this particular trapezoid? What's the distance from 3 to 4, which is going to be 1. And we still have to add to that trapezoid 3. Trapezoid 3 is going to be 1/2 times the bases. Let's do this trapezoid in, oh, let's just go blue. There's your third trapezoid. That's a crappy trapezoid. So what's the bases here? It's going to be the output for 4, which is 7, plus the output for 7, which is 2. And then what is the, my diagram is so busy I lost track of my x values. What is this base? It's going to be 7 minus 4, which is 3. And so that's an approximation for the integral from 1 to 7 of this continuous function f of x for certain input values. And I will let you do the arithmetic for this particular approximation right there. And there's another example, and you have some very nice problems to do for this. We've got about a 25-minute video. I'm going to call it quits on this particular video. I trust that you can take your calculator and multiply and add those numbers. Am I looking for a final sum? Nope. I am looking for the pieces of each term. That's what we're going to be looking for. The heights of the trapezoids, the bases of the trapezoid, and certainly the formula 1/2 sum of the bases times the height. So I will post a couple of problems for you to practice the trapezoidal method with. And thank you. Signing out.